Hello everyone. So let's try to solve one more problem from IE Irodov, and this is from the kinematics. And it is given this is problem number 1.6. It is given a ship is moving along the equator to east with velocity v naught 30 km per hour. The southeastern wind blows at angle phi, that is 60 degree, to the equator with velocity v is equal to 15 km per hour. Find the wind velocity v dash relative to ship and the angle phi dash between the equator and the wind direction in reference frame fixed to the ship. So it's a very nice problem. So this problem belongs to the relative speed and Galilean transformation. So let's try to understand what is the basic fundamental behind this relative speed. So let's try to go for that one first, and then we can easily solve this one. So suppose I have one frame, this frame is S, another frame, this frame is S dash. And what I have velocity of S dash with respect to S. Let's say it is in I cap direction. So this velocity S dash with respect to dash is given. This one is the value and this is direction. And there is one particular velocity, and this is your velocity of some particle with respect to S dash. And let's say this value is equal to Ux dash plus Ux dash I cap, Ui dash J cap plus Uz dash K cap. Then what will happen? Then velocity of a particle with respect to S, and that value is equal to velocity of a particle with respect to S dash in I cap direction plus Ux dash. And this is nothing but velocity of a particle with respect to X dash in I cap direction. And what will be, and this is the complete velocity in I cap direction, and velocity of a particle with respect to S in J cap direction is exactly Ui dash, and velocity of particle with respect to S in K cap direction is exactly Uz dash. So this is the whole story we have to understand. And you can have this velocity particle with respect to S dash, you can have any component x, y, z, but here we are fixing S dash with respect to S is along I cap direction, then we can go for this particular formulation. So let's try to what is given into this particular problem, and we will use all this algorithm. So let's try to go for this one. So what is given? So this is my north direction, and this is my east, this is north, east, this is south, and obviously this is west. The ship is moving along east direction V naught. So I am just putting it, this is my I cap direction. And this is velocity of a ship. So suppose this is your some ship and I am denoting it by SH. And the southeastern wind, what is meaning of southeastern wind? The wind which is coming from the southeast. So the southeastern wind, I am taking some another color. So this southeastern wind is coming into this particular direction, something like this, and which is making angle phi with x-axis, and this has velocity v. So this is the velocity of a wind. And what we have, we can write each and every expression, and this angle is phi. So we can write each and every expression. So what is this one? So velocity of a ship with respect to Earth, and that is V naught, and that is in I cap direction. Velocity of a wind with respect to Earth, E is the Earth, don't confuse with this east, E is the Earth, is we can just take a component along this side and this side. So that value is minus V cos phi I cap plus V sin phi J cap direction. So this is the whole story we can have, something like this. So I can write separately also. So this is velocity of wind with respect to Earth, that is minus V cos phi I cap plus V sin phi J cap. Now, what we have to do? We have to find velocity of a wind with respect to ship. We have to just find this one in a vector form. So we will just go for a component wise and we can easily go for this one. So what we have to find basically, so what we will do, we will just keep my ship, I will assume my ship is S frame and wind is my particle. And what will happen, this earth is my S dash frame. So this ship is my S frame, this is S dash frame, wind is my particle and this will be my S dash frame. So what is given? So in this particular problem, it is given velocity of what we need this formula, velocity of a particle with respect to S is equal to velocity of a particle with respect to S dash plus velocity of S dash with respect to X. I am just talking about I cap direction, and J cap and K cap has not any problem. So we have to just talk about the I cap first, then we can go for another component also. Here velocity of a particle with respect to S dash is given. So this is my I cap direction. So velocity of a particle with respect to S dash in I cap direction is minus V cos phi. And what we have to go for velocity of S dash with respect to S. So velocity of S dash with respect to S. So it is given velocity of S with respect to S dash is V, and we have to find velocity S dash with respect to V. So this is your minus V in I cap direction actually. And what will be this formula? So velocity of a particle with respect to S is equal to, we can put it there. So this value is equal to minus V cos phi plus, we can go for minus V naught. And this value we can write minus V naught plus V cos phi. So this is in I cap direction. What about in J cap direction? J cap direction is not any relative velocity. So velocity of a particle in S cap, that is in J cap, will be remain same, V sin phi. So what will be the velocity vector if we are going to calculate this one? Then we have Ux, that is X component, velocity of a particle with respect to S, or velocity of a wind with respect to ship in I cap direction is basically minus V naught. This value is minus V naught plus V cos phi. And what is your Ui? That is velocity of a particle with respect to S. This is in I cap direction. This is in J cap direction. That is velocity of a wind with respect to ship in J cap direction is not any problem. That is V cos phi. And what will be my velocity of a wind with respect to ship is minus V naught plus V cos phi I cap direction plus V. Sorry, this value is sin phi actually. This value is sin phi. So this will be your V sin phi in J cap direction. So this is the condition, and if we want to go for the speed, then we can just go for this one. So this value is V naught plus V cos phi mod square plus V square sin square phi. So what is this value? So this value is equal to V naught square plus V square plus 2 V naught V cos phi. So this will be the answer. This is the magnitude, and we can find the value of tan phi dash. Tan phi dash is y by x. We will take the magnitude only. So we will have V sin phi upon V naught plus V cos phi. So this will be my tan phi, and we can easily calculate this one. So it's a wonderful problem. Only what you have to do, you have to just understand what is your S frame, what is your S dash frame, and you can easily solve this one. So this is a wonderful problem, and you can easily solve this one. Thank you.